So on our synthetic division in 3.2, remember you always ask yourself first, what would make this 0? What would be the 0 here? Negative 2. And that's always what you want to divide by, is what would make it 0. And we're going to find out the significance of that terminology in a little bit. Now, you put in here our highest exponent is this x to the 5th. I'm just going to write it up there because I know when I divide, x will go down a degree. So put your coefficients in. You got 1, 3, 2, 2, 3, and 1. And always underneath your constant term is where you get your remainder. Now, like I say, your book, they do more of a division sign looking like that. And you can pick the way you like the best. You always bring the first number down, so we bring the 1 down. And remember, you multiply times what's on the bottom row, and we add in the box. What's negative 2 times 1?
Negative 2.
Negative 2. 3 plus a negative 2 gives you 1. Negative 2 times 1 is negative 2. That subtracts to 0. Negative 2 times 0 is 0. 2 plus 0 is 2. Negative 2 times negative 2 would be negative 4. 3 plus a negative 4 is negative 1. Negative 2 times negative 1 is positive 2. So I get a remainder of 3. Okay there. Now remember, when you divide this thing here, when you divide this polynomial, this fifth degree polynomial, by x plus 2, this is the answer. And it goes down a degree. Because if you said x to the 5th divided by x, you get x to the 4th, right? So you would say this is equal to x to the 4th plus x cubed. These are the coefficients in front of the next one. There's not an x squared term, so you'll leave it off, because 0 times x squared would be 0, plus 2x minus 1. And you always write your remainder over what you were dividing by. So that would be my answer there. Let's see here. Let's look at another. Okay, next, let's say if I have, for an example, 3x cubed minus 4x plus 2, all divided by x minus 1. Okay, well first of all you got to ask yourself, what's the 0 here? What number would make this 0?
1.
1, so that's what we're going to be dividing by in our synthetic division. You got an x cubed is your highest exponent, coefficient is 3. We're missing the x squared term, so what do I fill in for the coefficient?
0.
0. This is a common mistake that most people forget to do, is fill in those missing terms with a 0. So you got your x cubed term, the x squared term, our plain x, and our constant. Let me give you a minute to see if you can do the synthetic division to get the answer. let's see what we got. You brought your 3 down. 1 times 3 is 3. 0 plus 3 is 3. 1 times 3 is 3. Negative 4 plus 3 would be negative 1. 1 times negative 1 is negative 1. 2 minus 1 gives me 1, right? So that means my answer would be, if this was an x cubed, this would be 3x squared plus 3x minus 1 plus 1 over x minus 1.
So why is that first term and it's 3x squared again?
Because it'll always drop down 1 degree. If you divided, say, x cubed by x, and this x would divide out with one of those and leave you with 2. So it'll always go down just 1 degree. So that's the reason I always write that first term up there. So I know when I write my answer to drop it 1. Now if you wanted to check this problem, remember we said we could check it by the division algorithm? You could say what you were dividing by, this x minus, this whole problem, the f of x, that numerator, x minus 1 times the answer you just got, x squared plus 3x minus 1, plus the remainder. If you multiply this through, you should get your original back. Same way you check regular division problems. You multiply your answer times what you got and add your remainder, right? So if we actually did that, let's look at this one real quick since we didn't do one last time. You got to do that repeated distributive property, so I need to say x times 3x squared plus 3x minus 1 minus 1 times 3x squared plus x minus 1 plus that 1 with the remainder. If I do the distributive property, that's 3x cubed plus 3x squared minus x minus 3x squared minus 3x plus 1 plus 1, right? And if I combine like terms, you have your 3x cubed term. You see here your x squared terms, subtract to 0. Negative x minus 3x is negative 4x, and 1 plus 1 is 2. So you see you get your original problem that you were dividing by that. And that's if you wanted to check it, write it in terms of division algorithm. Let's look at this one over here, and this is going to lead us into our next topic. Let's see if you can do this one from scratch. I think you're looking real confident today, so I think we might can handle that quiz. Remember, the more quizzes you have, the more you get to drop. Y'all come to school without pencils? I don't have a eraser, so don't mess up. At least you can write something. You don't have paper in it? All right, what would make the 0? What would be the 0 of this x plus 3? Negative 3. We always, like I said, divide by the 0. This is an x cubed with coefficients 1. The next coefficient's 2, negative 1, and 6. So every term here was here. Notice, what's this highest power? Cube. 3. So when you'll always have one more than that, whatever that degree is for your terms across here. So if you get worried that you don't know if you've left a term out, if this exponent's a 3, then you should have 4 terms going across, so you've got a constant term. Okay, so you got your x cubed, x squared, plain x, no x. Alright, so you brought down the 1. Negative 3 times 1 is negative 3. Add in the box. 2 minus 3 is negative 1. Multiply here. Negative 3 times negative 1 is positive 3. Negative 1 plus 3 is 2. Negative 3 times 2 is negative 6. So we get a remainder of 0. Okay? So that means I can say that this function here is actually equal to x squared minus x plus 2. No remainder. Okay. Now you're fixing to learn the beauty of what we're working our way toward. I'm going to jump ahead and enlighten you on what we're going to have to do. Since anytime you get a remainder of 0, that means that whatever you're dividing by is a factor of that. Just like if you divided 2 into 24. You'd say 2 goes into 24 12 times, the remainder is 0. And do you agree that 12 is a fact, 2 and 12 are both factors of 24? That's what happens on this. If your remainder is 0, that means that whatever you're dividing by, x plus 3 is a factor of that. So we're going to get ready to solve these equations. And once you get it down to a quadratic, you know how to solve a quadratic equation, right? You could solve it by factoring, except here there's not any factors of 2 when you add it give you negative 1. But you could solve it by the quadratic equation. And how many answers is this polynomial going to have? 3. The highest exponent tells you how many answers you get. Well, one of the zeros are your answers, your x-intercepts. One of the zeros would be negative 3, and you could do quadratic formula to get the other 2 zeros. And that's where we're going in the rest of chapter 3. Okay? Let me ask you this. Alright, I want to ask you, if you are, this is like what you did on your last test. If you are given, let's say f of x is equal to 3x cubed minus 4x plus 2, and I want you to find f of 1. Do it just like you did on your last test. Remember, when it's in function notation, whatever's in that parentheses, that's what you're going to place all your x's, right? So that means I would have 3 times 1 cubed minus 4 times 1 plus 2, or that's 3 minus 4 plus 2. That's negative 1 plus 2, which is 1. Notice that? F of 1 equals 1. Would you notice this is the same problem I had right here? When I did synthetic, this is my f of x. When I did synthetic division, what was my remainder here? 1. Same thing you get when you plug these in. That is on your sheet. That's the remainder theorem on that note sheet that I just gave you. The second one. On the online class, I emailed all of them the same sheet. So I'm going to put another little definition up here, but if you don't want to write it down, it's on your note sheet. So you have the remainder theorem. And the remainder theorem tells you that if f of x is divided by, say, x minus k, then k, which is the 0, when you put that k in here, that would be what would make that 0. Then k, well, let's say the delta k. Then k, which is a 0, that you're divided by, will give you f of k, which is equal to the remainder. Whatever the remainder is, I don't know why I put this in. If f of x is divided by x minus k, then the remainder is equal to f of k. So I've got a little word here. That if f of x is divided by x minus k is your 0 that you're dividing by, little wordier. I think it might be worded better on the sheet. But on your sheet, you see here, the polynomial f of x is divided by x minus k, then the remainder, f of k equals the remainder, just like what we had here. And you might be thinking right now, well, I like doing it this way better. Okay? Well, let me show you sometime when you might not like that way. Let's say if we have a problem like number 36 here in your book. On 36 in the book, you're given f of x is equal to 6x cubed minus 31x squared minus 15x. And you're told here k is equal to negative 1/2. Find f of k, which would be f of negative 1/2. So you're told for each polynomial, use the remainder theorem and synthetic division to find f of k. So for this one, we want to find f of 1/2. Well, yeah, you could go in and put a negative 1/2 in place of all those x's, but that's really going to be harder than just doing your synthetic division. Now notice here, you're given k. It's not written as a factor like those other ones was. You're given k. K is the 0. That's what you're given. So you're going to do synthetic division with that negative 1/2. You got your x cubed, which is a 6. X squared is negative 31. Negative 15. You don't have a constant term, so put a 0. Now on these, the only time that you ask yourself what makes it 0, that you change the sign on what you have, is if it was written as a factor. If it actually gives you k, k is always what you divide by. K is always the 0. So bring down my 6. Well, what's negative 1/2 times 6?
3.
Negative 3, right? 2 goes into 6 3 times. Negative 1 times 3 is negative 3. Now, negative 31 minus 3 will give me what? Negative 34? So we got to find out what's half. So a negative times a negative is going to give me a positive. And what's half of 34? 17. Negative 15 plus 17 gives me 2. Well, negative times a positive is going to give me a negative. What's half of 2? 1. So I get negative 1. So that means this is equal to f of negative 1/2 by the remainder theorem. And to me, this is actually easier than actually going in and cubing a 1/2, getting a common denominator, and adding and subtracting.
So we write it like that?
Yeah, if all it wants to know in this remainder theorem is what is f of negative 1/2, and it's just whatever the remainder equals. You don't have to write the answer. It's not asking you to give the answer or anything. Okay. Well, next on this sheet, we're told, given a definition about the 0 of a function. So if you look on your sheet, and this is actually the 0 of a polynomial is the first one on your sheet. You're told that a 0 of a polynomial function, which is also your x-intercepts, it tells you that whatever your degree is, that's how many you have. It says that you will, is if your remainder is 0. That means the number you're dividing by is the 0 of the function. So we're talking about zeros of a function. If you divide by k, which is the 0, or what you think is the 0, and the remainder equals 0, then k is a 0 of the function. K is a 0 of f of x. And this is your factor theorem. And x minus k is a factor of f of x. So when you divide by k, what you think is the 0, if your remainder is 0, that's like what I was telling you earlier, then that number is a 0 of the function, and x minus k is a factor of f of x. This bottom part right here is actually called the factor theorem on your worksheet. Okay, so let's look at a few of these problems. Let's say if I want to know for example 1 here, I think this is actually number 52 in your book, but if I'm given f of x is 16x to the 4 plus 4x squared minus 2, and I'm given k equal 1/2, and I want to know is k equal 1/2 a 0? Okay? So I'm given a function, I'm asked, is k equal 1/2 a 0? Now this is all you're going to do in 3-2, and then we're going to add this factor stuff on there.
That 4x cubed is it squared?
Squared. Sorry. So that means I'm going to have here the 1/2, I'm given my k, I'm given an x to the 4th term, which is 16, missing the x cubed, so fill in with a 0, x squared is 4, missing the plain x, so put a 0, and then you have negative 2. So if it's a 0, what's my remainder going to be? If 1/2 is a 0 of this function, it means this is an x-intercept on this graph, what will my remainder be? Okay, well if you have an x-intercept, how's the x-intercept point written? If 1/2 was an x-intercept, would it be written as x is 1/2? What's the y's on all the x-intercepts? 0. So that means if my remainder is 0, if your remainder equals 0, then the number you're dividing by is a 0 of the function, which means that x minus that number would be a factor. Okay, so let's see if we get a remainder 0. That's going to be your whole goal on this next test, is you're going to want these remainders of 0. You're going to hope and pray that whatever you're dividing by gives you a remainder of 0. That's going to be the key. What's half of 16? 8. 0 plus 8 is 8. What's half of 8?
4.
4 plus 4 is 8. What's half of 8 again? 4. 0 plus 4 is 4. What's half of 4? 2. So I got a remainder of 0. So that means my answer is, that means that f of 1/2 equals 0. So 1/2 is a 0 of f of x. Okay? So by the remainder theorem, 1/2 is a 0 of this function because my remainder was 0. That means if I wanted to start factoring this, I know one of my zeros. Okay? I'm going to hold on to this one for a second, and I'm going to do another. Then we're going to come back to that. So leave a little bit of space over on this right here on this part. Example 2. You're given f of x is equal to x cubed plus 2x squared minus x plus 6. And I'm asking, is k equal negative 3 a 0? X cubed, 1, 2, negative 1, and 6. So we bring down my 1. Negative 3 times 1 is negative 3. 2 minus 3 is negative 1. Negative 3 times negative 1 is positive 3. Negative 1 plus 3 is 2. Negative 3 times 2 would be negative 6. So I did get a remainder of 0. So what will my answer be? Yes or no?
Yes.
Yes. Because my answer was 0, the answer up here is yes. Alright, let me show you something we'll need here. So we know by the remainder theorem that f of negative 3 equals 0. So negative 3 is a 0. And look what I talked about that factor theorem. I told you then if k is a 0, then you can write an x minus k has to be a factor. So this kind of goes back to what we did a while ago. Well, if negative 3 is a 0, then x minus a negative 3 would be a factor, right? What's these two negatives make? Pi. So it's really x plus 3 is a factor. Remember, if it's a 0, the sign will be the opposite. You with me there? Let's think. Okay. -3, by the remainder theorem, I got a remainder of 0. If your remainder is 0, that means that that will be an x-intercept on this function. Okay? Alright, next, by the factor theorem, you're told if a number is a 0 of a function, then x minus that number is a factor. Because what we're going to be doing is we're going to be taking these big higher order polynomials and we're going to factor them completely. We're going to find all the zeros. And we know this one has 3 zeros. We just found one of them. And that means if -3 is a 0, x plus 3 is a factor. Remember like what we did on homework today? You would have something like this divided by x plus 3. And I asked you what makes that 0. And you told me -3 the opposite. Well, now you're going the other way. You're saying you're given the 0 and you're going to write the factor, the x plus 3.
Oh.
Okay? Well, this is now we're going to put together what we did for homework today again. So if x plus 3 is a factor, you agree that I can write this cubic polynomial. My answer here would be, I'm going to say my factor, x plus 3, what I was dividing by, times, that was the x cubed, so this would be x squared minus x plus 2, right? X squared minus x plus 2. So if I multiply this back through, I should get my original back. And if we ever want to find all of my factors, I would try to factor this one, which again, factors of 2 when you add won't give you -1. But if you wanted to find all 3 of those zeros, you've got -3, and you could actually do quadratic formula to get the other 2. And that's where we're going. Okay? Let's look at another, let's go back to this one now. I didn't want to start out my first one with writing the factors being one with a fraction. Okay, so if I wanted to write this one, since 1/2 is a 0, how would I write the factor? Then x minus 1/2 is a factor, right? X minus the k. Well, think about on that first test when you were factoring all these quadratic equations. Did you ever write one as x minus something with a fraction? All right, I'm going to tell you a real quick shortcut way to write this, where 1/2 is a factor. Whatever's in the denominator, make it the coefficient in front of x. X minus 1/2 is the same thing as 2x minus 1. Just whatever's in the denominator, put it in front of x. Because what would happen, if I put 1/2 in, what's 2 times 1/2? 1, and 1 minus 1 is 0. So these things right here are equivalent. So what you would do, whatever's the denominator, just throw it up there as the coefficient in front of your x. So on this one, you'd say f of 1/2 equals 0. So 2x minus 1 is a factor. And then this will be a cube, and we'll find out probably next week. You have to keep doing synthetic division over and over until you get it down to a quadratic that you can solve by quadratic equation or by factor. All right, let me throw something else on you. This part you're not going to like it quite as much.
Is this still section 3.2?
Yes, this is still 3.2. That factor theorem, writing the factor is actually into 3.3, but they kind of blend together, so we put them together. All right, so this is still 3.2. If you're given number 3, if you're given f of x is equal to x cubed minus x squared plus 9x minus 9, and you want to know is k equal 3i a 0. These are going to be your least favorite. Now it's going to work just like these other ones. If my remainder is 0, your answer will be yes. And x minus 3i is a factor. Okay? But you got to remember how to multiply and add complex numbers. Let's set it up. This is my x cubed, which is 1, -1, 9, -9. Leave a little bit of space between those numbers too. Alright. Everybody ready? You might want to watch this first one. You might want to watch it and then write it down. Bring down the 1. What's 3i times 1?
3i.
3i. Now do you agree these are not like terms? Remember on complex numbers you can only combine like terms. So that means this will be -1 plus 3i. right, Will? Okay, now you need to multiply. You need to say 3i times negative 1 plus 3i. So we got to multiply complex numbers. What's the key thing you have to remember when you're multiplying complex numbers? What was I squared equal to?
Negative 1.
I squared equals negative 1. You got to remember that. So when I distribute this, that's going to give me negative 3i plus 9i squared. And what did you just tell me I squared was?
Negative 1.
Negative 1. So that's going to be negative 3i plus 9 times negative 1. Or that's negative 3i minus 9, right? But how did we always have to write a complex number? The real part had to be first. Remember, it was a plus bi. So that means this is actually negative 9 minus 3i. Remember I told you this would be your least favorite ones? I'm going to give you a big 5th degree polynomial where you're going to find all 5 factors, and you're going to like that better than this. So up here I've got negative 9 minus 3i. Okay, now what happens to 9? We can add our real parts. 9 minus 9 would be 0, so I'm just left with a minus 3i. So now I need to say 3i times negative 3i, which will give me what? Negative 9i squared. And what's I squared again?
Negative 1.
So it's negative 9 times the negative 1, which is positive 9. So what's my remainder going to be?
0.
0. So is k equal 3i 0?
Yes.
Yes. Because f of 3i equals 0. So that means x minus 3i would be a factor of this polynomial. Alright. Let me show another one with the I so we can
Can you
just
let us write that down real quick?
yeah, I'm going to let you write it down. I'm going to erase everything while you're writing. Now this is my favorite section on this whole test. There's going to be a lot of little stuff. Pretty much if you can do synthetic division, everything else is going to fall into place. You're going to get a remainder of 0. It's a 0 of your function. You can write the factor, x minus that number. And you can do that for as many times as you're going to need to go. Now I probably wrote down a little bit more of that multiplying on that first one than you might necessarily need.
We need to do a refresher on the
Complex numbers. That's the one thing about algebra is no matter what you do, from day 1 all the way to the end, you keep doing it over and over. You can't forget anything. So complex numbers are going to come back. Factoring is always big. But the good thing about it is you're going to do this stuff so many more times when it gets to your final exam, and you have just one of multiplying complex numbers, you're going to be so good at it that you're not really going to have to go back and study it a whole lot because you're going to remember it. All right, we good? All right, let's look at one more like this. This is actually number 54 in your book. Still in 3-2. You're given x squared minus 4x plus 5. And you want to know is k equal 2 minus I a 0? Remember, leave a good bit of space. X squared, which is 1, negative 4, 5. Everybody with me and ready to start multiplying? Everybody got it written down? So we're going to bring down our 1. Well, 2 minus I times 1 would be 2 minus I, right? Well, now on complex numbers, you can add the like things. You add the real parts and you add your imaginary. So I have negative 4 plus 2, which is negative 2 minus I, right? So now I need to multiply 2 minus I times negative 2 minus I. Well, what do you have to do when you're multiplying a binomial times a binomial? Form method. So let's do form. Well, 2 times negative 2 is negative 4. Outside would be minus 2I. Negative I times a negative 2 is a positive 2I. Negative I times negative I would be positive I squared. Doing form method, right? So far, so good? Alright, let's clean it up some. What's going to happen to those 2 i's? They subtract out. What's I squared equal to? Negative 1. So really I have negative 4 minus 1, which is negative 5. What's negative 5? What's 5 plus a negative 5? 0. So once again, your answer is yes. And you could say that x minus, put these in parentheses if it has more than one term. X minus 2 minus I is a factor. Because you agree here, even though this is a quadratic equation, if you wanted to solve it, there's not any factors of 5 when you add that give you a negative 4. 5 plus 1 is always 6. So if you want to solve this quadratic equation by the quadratic formula, you would actually, you'll find you'll get 2 plus or minus I as your answer. We're going to find out in a little bit. Anytime you got an I, the conjugate one's always a 0 too. They come in pairs. So far, so good. Let's look at this one, just because I need to give you one that works like this too. Alright, you should do this one pretty easy. It's 4 a 0. You've got your x cubed, which is a negative 1. Your x squared is 8. You're missing the x term. And you got a 63. You brought down the negative 1. 4 times negative 1 is negative 4. 8 minus 4 is 4. 4 times 4 is 16. 4 times 16 is 64. What'd you get as your remainder? 127? So is 4 a 0? No. So you're going to like this one. You just put no, and you don't do anything else. You're done. The only time it's going to mean anything to you is going to be when that remainder is 0. You should like that one, because hopefully you won't get many of those, because you're not going to like it later on when your answer is no. Alright, now this is that 3.3. This is where we talked about that factor theorem that I just gave you that we're already actually doing, where it says if your remainder is 0, then x minus that number is a factor. So I'm going to give you 2 examples here. This is number 6. You're given f of x is equal to x cubed plus 6x squared minus 2x minus 7. And then you're asked, is x plus 1 a factor? Once again, this is going to be a yes or no. It's the same thing we've been doing, but it's asking, it's giving it to you in factored form versus just k equals. Now I just told you on the remainder theorem, if your zero gets a remainder of 0, then yes, it's a factor. So what do you think I need to do here? What am I going to divide by? Negative 1. Right, remember you ask, if it's written this way, you ask yourself, what makes it 0? Negative 1. So we need to know it's negative 1. This is x cubed, we get 1, 6, negative 2, negative 7. Well, if my answer is going to be yes, what's going to happen here? The remainder is equal to what if my answer is yes?
Negative? No.
0.
0. You'll get a remainder of 0. Remember, you always want that remainder of 0. So when you divide this by negative 1, if your remainder is 0, then your answer is yes. Negative 1 would be a 0, and x plus 1 is a factor. So bring down the 1. Negative 1 times 1 is negative 1. 6 minus 1 is 5. Negative 1 times 5 is negative 5. Negative 7. Negative 1 times negative 7 is positive 7. So I got a remainder of 0. I like this one. So I can say that f of negative 1 equals 0. So x plus 1 is a factor. Which means my answer is yes. So far, so good. Now, this is where we get to the good problems, like in number 18 here in your book. You're told to find all the linear factors and zeros. On number 18, you're told that f of x is equal to 2x cubed minus 3x squared minus 5x plus 1, and you are given that k equal 1 is a 0. Alright, I want us to think a minute here. If k equal 1, how many zeros is this problem going to have? 3. That's the fundamental theorem of algebra. Your highest exponent gives you the number of zeros. So it has 3. If k equal 1 is a 0, that'll give me 1, and it'll take it down to x squared, and I can find the other two by factoring or quadratic formula. I can find all 3 zeros. Okay, well, if k equal 1 is a 0, and it's telling you it is a 0, so your remainder better be 0, what would the factor be? If k equal 1 is a 0, how would you write the factor? Remember, your factors are always x minus k, so it would be x minus 1 would be a factor, right? If k equal 1 is a 0, then x minus 1 has to be a factor.
I don't get how to write the factor part.
Okay, whatever your 0 is, let's say if I had something, let's say if I had this. If you just did the quadratic equation that factored into this, and you're wanting to solve. How would you solve this? X plus 2 equals 0 when x is what?
Negative 2.
Negative 2. That means negative 2 is a 0, and here 3 would be a 0 of that function. If you put either one of those two numbers back in place, you get 0. Well, what this is doing is this is giving you the answer first. So it gives you the answer, and you've got to write the factor. Because like here, negative 2 is a 0 of x plus 2. You write it back.
You just write the opposite.
It's the opposite. It's x minus what you have.
Say it like that, that makes
Yeah,
sense.
that's a 0. Hey,
Right.
That lingo made sense better than the.
Okay, good deal.
okay.
Alright, but you always write a factor as x minus the k. And minus means the opposite. Okay. So if 1 is a 0, then x minus 1 is the factor. Because what would we get if we put a 1 in place of that x? 0. Okay. So we're going to divide this by 1. This is my x cubed, which is a 2, negative 3, negative 5, and 6. Now if it gives you as a 0, it has to get you have to have that remainder of a 0. Bring the 2 down. What's 1 times 2? 2. Negative 3 plus 2 is negative 1. Negative 1 times negative 1 would be negative 1. Negative 5 minus 1 is negative 6. 1 times negative 6 is negative 6. So we did get the remainder of 0. So get in the habit of putting f of 1 equals 0. X minus 1 is a factor. So that means I could write this function, this f of x now, as x minus 1 times, now this is x cubed, so this will be the coefficient in front of x squared, 2x squared minus x minus 6. Now, this one we can factor. I can find all 3 factors right here, all 3 linear factors. I can go ahead and factor this some more.
So you put the x minus 1 in front of everything?
Yes.
Okay. Do we gotta do that part?
How about
Well, you're
yes?
gonna have to tell me all the linear factors.
So yes, you just wouldn't take yes.
No, this one didn't do yes or no. This is you gotta write all 3 factors and you gotta write 3 zeros. So this is gonna be my linear factors. I'm gonna have the 2x and the x. Let's see, we want a 1 in the middle, so let's put 3 here and the 2 there. Minus 4 plus 3. So this is my linear factors. Every one of them is a factor. So I found all 3 factors. I have completely factored this 3rd degree polynomial. Once you get it down to a quadratic, you can usually do it by factoring, or on all the ones you're going to do for homework. Now you can tell by looking, what are my zeros? What made this one 0? 1.
Negative 3.
This would be, 2x plus 3 would be 0 when? Negative 3 halves. And what would make x minus 2 0? 2. That's your answer there. How did I know that was negative 3 halves?
Because the 2 is in the denominator.
Right. 2x plus 3 equals 0. When 2x is negative 3, divide both sides by 2. So you get x is negative 3 halves.
So like on the test, you're gonna say zeros and then 3 blanks?
Now I'm going to have linear factors, a big blank, zeros, and a big blank. Alright, now what's going to happen here? Like I said, all the ones you're going to do will factor, but if they didn't factor, you can do quadratic formula to find them. Let's see. I'm going to let you take that quiz take home. So let's look at another one. Also, I don't know what I was going to tell you. On that particular problem, if you had divided f of x here by 2, you would have got a remainder of 0. If you had divided by negative 3 halves, your remainder would have been 0 on all of those. Let me show you something. I was turning this on. Before we do another one, I'm going to show you what this graph looks like. This is going to be really neat too. What is a norm on that quiz, on that test you just took? What was the basic graph for a cube function? What did it look like? It looked kind of like that.
Oh,
A little squiggly going up. All right. What's going to be so neat about this is this one, because it's a 3rd degree polynomial, it's going to have this basic shape. It might do some funny curving around in there, but it's still going to have that basic shape of that graph. Now we're not going to graph these higher ordered ones, but it's real neat to look at them. Well, you want to make sure you're awake for this, because you might like to do some of yours this way with that calculator. All right, so I have 2x cubed minus 3x squared minus 5x plus 6. All right, so notice this looks like my basic cube function. You see your cube function? All right, notice here, how many x times does it cross the x-axis? 3. And look at where it crosses the x-axis. All right, look, I'm not lined up. These 3 places, you have positive 1, positive 2, and this is actually negative 1.5, right? What were my zeros? 1, negative 3 halves, and 2. Your x-intercepts will always be your zeros. So if you have a graphing calculator and you're trying to find all the zeros, you can graph it. Wherever it crosses the x-axis, that's your zeros. That's the answers to that problem, to that part. You could write your factors. X minus 1, x minus 2, and so forth. Okay, because your zeros are your x-intercepts.
So you telling us we can just put that in the calculator and just write the answer?
Well, no, I'm gonna make you show your work.
Oh.
But if you want to check it, and you had a graphing calculator, or on your exam, which is multiple choice, yes, you can plug it in, you can look at the graph on a graphing calculator. Alright, my next one that we're gonna do. Where'd it go? Alright, let's see if you can handle this one. If you're given f of x is equal to x cubed plus 7x squared plus 15x plus 9. And I'm going to tell you k equals, which one I want to do? K equals -3 is a 0. And you're going to want to find all zeros, and you're also going to want to list your linear factors. And normally this would be written the other way, factors first. So basically I need to do my synthetic division once to get this down to x squared that I can solve by factoring. What I'm handing you now, this is the take-home quiz that you're going to do and turn in Tuesday, so don't forget it. Everybody get one? The way it works? To me, this is the best part of this class. I mean, you can factor things.
If it's right what I got, now I'm smiling, but if it's wrong.
Well, it's right. The whole thing, to me, if you go up and you ask anybody that's ever taken the class, no matter what their degree is, if they had to take college algebra, you're like, what are the main thing you remember college algebra? They're either going to say quadratic formula or they say factoring, because that's what you do so much of the time. So now, instead of just having a quadratic that you can factor, you're going to be able to factor big, huge polynomials. And this gets used more if you go into business calculus. You know, a lot of times people, when they graph their different functions in a business, these graphs are called break-even points there. All right, so let's look. You bring down the 1. -3 times 1 is -3. 7 plus -3 is 4. -3 times 4 is -12. So I get +3. -3 times 3 is -9. So I got a remainder of 0. So I can say f of -3 equals 0. So what's the factor? If -3 is a 0, the factor will be
X plus 3.
x plus 3. Are getting good. So x plus 3 is a factor. So that means I can write this big third degree polynomial So my linear factors would be x plus 3 times x plus 1 times x plus 3. So what's my zero? What made this one zero?
-3.
What made this one zero? And you don't have to write that -3 again. That's going to lead us into our topic for next time. So we're getting good. Now what's going to happen is we're going to get to things where you're not going to be told the zeros. But I'm going to tell you ways you can find the zeros or narrow it down if you don't know it. Be sure you do that quiz and also do this homework. 3, 2, 27 through 57 odd, 3, 37, 5 through 21 odd. I put a star by 3, 3. If you at least do 3, 3, that covers 3, 2 as well. So 3, 3's homework is way more important than 3, 2. So do 3, 3, do this quiz, and all that good stuff.